G'day viewers, Dave Lonergan, Arctic Film Productions. Earth on Fire 2023. Now you could be forgiven for believing we're going backwards in our global efforts to reduce our greenhouse gas emissions, because in many ways we are going backwards. Our thirst for fossil fuels has only increased as our population surpasses 8 billion people recently. All the talk about reducing our collective carbon footprint, reducing our reliance on fossil fuels, it's not actually eventuating in any sort of reality. Now, greenhouse gases, they're on our planet, they're here to stay. Burning of fossil fuels, coal, oil and gas. Now if we're not careful, that scene from Kevin Costner's movie Waterworld, where the entire planet is encased in water, one day may eventuate. Sounds alarmist, yes, but in some nations in the Pacific region, that's exactly what they're getting right now, a water world. Due to global air temperature increase, pushing up the world's ocean temperatures, has a twofold flow-on effect across our planet. Let's look at the Pacific region. You start warming sea temperatures, it speeds up the melt in the Arctic and the Antarctic sea ice. So year-round, a reduction in the Arctic pack ice, the Antarctic pack ice, a reduction in that ice. And also, you're speeding up the glacial melt water feeding into our oceans right across the planet. Seawater expands as it warms. This is called thermal mass expansion. So, by accelerating the global ice sheet melt, right, the sea ice melting, thinning, you're allowing more solar radiation into the planet from the sun, heats up the water more, and you're losing that reflective ability of the pack ice to send, which is white, to send back solar radiation back into space. So that just heating up the atmosphere, firstly by greenhouse gas emissions, and you're heating up the atmosphere because you're allowing more solar radiation into the planet. So as sea levels increase in height, you're flooding into these low-lying lands, atolls, low delta regions, any low-lying city and town. The equatorial regions will be affected more than anyone else and quicker because their ocean temperatures are already warmer than they are in the southern hemisphere, northern hemisphere. Remember, thermal mass expansion, seawater expands. It expands, it pushes into the land on tidal surge, just pushes into land because there's more of it. Coal-fired power stations, big problem. We have 8,509 coal-fired power stations on this planet. 33% of all power generated comes from the burning of coal. It's a fossil fuel. It's non-renewable. So you've got coal, oil and gas, the main greenhouse gas emitters. Now, you've got to remember these are a one-burn option to supply primary energy resource. They emit carbon dioxide on burn. Greenhouse gas heats up the planet's air supply and hence heats up the vast oceans. Now, just look at China, one country, 3,037 coal-fired power stations, 3,037. India, 285, the USA, 240, Japan, 91, Indonesia, 84, Russia, 72, Australia, this is pretty interesting. There's only 25 million people in Australia, but they've got 19 coal-fired power stations. Not good, Aussies. Another big thing to consider and to be aware of is that we have 134 years supply of known coal reserves across the globe. 134 years additional ability to burn coal. And because it's a known way to generate electricity, when it's just there on the ground, go and dig it up and set fire to it, they keep doing it because it's easy and we've got shitloads of it. That's the trouble. Electricity generation worldwide from coal is 39%. Natural gas, it's another fossil fuel, remember? Sounds nice, natural, but it's still a fossil fuel. 24%. Hydro, 16%. Nuclear, 19%. Wind, 5%. Solar, remember the sun up there, it's free. It doesn't cost us anything, it just glows all the time. 3%, only 3% of power generation on the entire planet comes from solar. You just think, what are you doing? It's crazy. Bit of information for you. The world's first coal-fired power station, the Edison Electric Light Station, was built in London in 1883. It was basically built to provide street lighting for London and to heat the homes. But now, it's the biggest cause of greenhouse gas emissions on the planet. Not that one station, of course. It's the fact we just kept building more of them. Now, a coal-fired power station, it takes crushed coal, they dig it up, they crush it, they burn it to boil water, to create steam, to drive a turbine which spins to a generator to create electricity. It's pretty archaic, it sounds basic, doesn't it? That technology was developed 140 years ago. And although while today's coal-fired power stations are more efficient, the first coal-fired power station was built in the 1880s, we're still using the same method. It's the same. You're still burning coal, black coal, brown coal, dirty coal. Greenhouse gas emissions, carbon dioxide. Hello? Coal, biggest cause of greenhouse gas emissions on our planet. 50% of all coal dug out of the ground and burnt was in one country, China. 2020, the worldwide number of coal-fired power stations started to fall slightly across the globe, but in China they started to increase the number of coal-fired power stations. Then you got gas-fired power stations. The first real gas power station opened in Switzerland in 1839. Natural gas now accounts for 24% of all power generated on the planet. From that, started out with 1. Remember, natural gas is a fossil fuel. It's mainly methane. It's a greenhouse gas emitter. It's the same. It's just slightly, it's not as dirty as coal. The highest number of gas powered stations is in Russia, 177. China, 163, Germany, 131, Italy, 111, Mexico, 104, Iran, 81. The big polluters, no surprise here, China, USA, India, Russia. Now, this is pretty interesting. The USA has got a population of 331 million, last time I counted them. China has a population of 1.412 billion, but in reality, the USA is the biggest emitter of greenhouse gas per capita, so per person, on the planet, followed by China. The biggest, the USA. During COVID-19, greenhouse gas emissions dropped slightly, but have certainly ramped up again, full speed ahead. World fossil carbon dioxide emissions, 1970 to 2020. The big culprits again, the US, India, Russia, China. Just remember, we've got 134 years supply of known coal reserves on the planet to keep burning away. Known gas reserves, another 52 years supply. Now, another thing to keep in mind, greenhouse gas emissions don't only come from electricity generation. Transportation accounts for 24% of global carbon dioxide emissions, primarily coming from burning fossil fuels for our cars, trucks, ships, planes, trains, whatever. 90% of all fuel used for transportation is petroleum-based. It's a fossil fuel, gasoline, diesel. USA, naughty peoples, 29% of all US greenhouse gas emissions comes from their transportation sector. That's a third. That's the largest source in the US of greenhouse gas emissions, just from transportation. The EU countries, an increase in greenhouse gas emissions from transport over the years because their population is increasing. A slight decrease during COVID-19, but it's certainly ramped up again. Many stats are predicting a decrease in greenhouse gas emissions from transportation in Europe as the slow switch over to EV cars, electric cars. Let's just hope this coincides with switching from fossil fuel burning as a primary energy resource to power electric cars. Get over to renewable, solar and wind. Crazy. In 2023, 72% of global transport emissions came from road vehicles. Interesting. Now, there's been an 80% increase in road transportation emissions from 1970 to 2021. 80% increase. Now, the USA is by far the biggest contributor to transportation greenhouse gas emissions. Second to China and India, but the USA is the biggest with only 331 million people. Transport vehicles worldwide in 2022, 4% of all cars and trucks were electric powered. 4%. Now studies are predicting that by 2025, which is in 2 years' time, this would increase to 10%. I can't see it happening. Scandinavian countries, they're the biggest users of EU electric cars, electric vehicles. Norway, 58%, this is very commendable, of all new car sales in Norway are EV cars, electric cars. But they've only got a population of 5.8 million. Now, you look at the USA, right, 331 million. In 2022, that's the last figure I could get, 4% of new car sales, 4% were electric cars. You can see the problem. The big users aren't switching over to renewable. They're still burning fossil fuels. So it's slow changeover. Another very slow burn from fossil fuels to renewable is the solar market. On housing and business, 3.9% of homes in the EU, US, Pacific and Australia use solar as part of their power needs. 3.9% use solar as part. This is very, very slow. The data's conflicting, but governments would need to be offering tax credits, rebates to homeowners and business owners to encourage the take-up of solar. Let's look at Australia, all right? It's my home country, I'm an Aussie. Highest solar radiation on the planet. What that means is that in Australia, we have the potential to harness energy from the sun, it's free, more than anywhere else on Earth. It's just the way our country is situated. 1.98% of power generated in Australia is from solar. Now, these installations in Australia are expensive and the government rebates are low. The bulk of the equipment, batteries and panels, it's not produced from Australia, it comes from China. Crazy. The highest number of solar-powered power stations is in China, biggest population. One of the biggest populations, 35%. US has got 11%, Japan 7%, Germany 6%, India 6.2%, I think. Australia, now remember, this is the country with the highest solar radiation potential on the planet. Yeah, 1.98%. Great. The planet's biggest user of coal is China. 337 operational coal-fired power stations, and they currently have under construction more than half of the world's new coal-fired power stations. Now, the Chinese leaders a few years ago announced that by 2060 they'd be carbon neutral. Yeah, great, sure. But since then, they've accelerated their exploration of and their use of of fossil fuels. So they've just increased their greenhouse gas emissions, which then affects air temperatures and ocean temperatures, just like everywhere else on the planet. It doesn't just affect the country where they're generating the electricity or the power, whatever they're using it for. We're all on the same planet. So if you're burning coal in Australia or burning coal in India, you're burning coal in the US or in China, you're not just heating up your own backyard, we're all in the same backyard. There's no planet B to go to when we fuck this up, and that's what we're doing. Information available shows that China has 165 new coal-fired power stations under construction right now, 165 more, because they're expanding their industrial economy. They're only going to increase their use of fossil fuels. I've seen no data at all to see there's any intention to move away from fossil fuels in China. You know, that's one of the biggest problems. The bigger countries are causing the biggest problems, and they're still going in the same way. China also boasts 189 operational gas-powered power stations. Gas is natural gas. It's fossil fuel. Fossil fuel exploration in the Arctic region. It's another issue that's coming up. Well, it's already coming. It's already here. As the world's ocean temperatures increase, the ice melt has accelerated. So previously inaccessible Arctic regions are becoming more accessible for oil and gas exploration. Now, preliminary studies have shown that the Arctic region holds another 25 to 35% reserves of usable crude oil, easier to access than it was 20 years ago. Wonderful. This region is going to be exploited as our need for oil and gas only increases as our population increases. This fragile and remote region, it's going to be plundered as other regions have been. Ironically, huge infrastructure set up in the northern regions are becoming affected because the permafrost frozen ground is thawing out because the air temperature is increasing because we're pumping out so much greenhouse gas emissions into the air, and the ocean temperatures are increasing. So the frozen ground, northern Canada, Alaska, Siberia, it's starting to thaw out. So the infrastructure they set up to access the fossil fuels is becoming unstable. It's a bit ironic, isn't it? Russia is investing billions into oil and gas infrastructure, new infrastructure, concentrating in Siberia because they're going to get better access to the Arctic. So, more fossil fuels. The Arctic region is warming faster than anywhere else on the planet due to our lack of reducing our reliance on fossil fuels. So you're getting this overall coverage of ice in the Arctic is reducing. So it's reducing in the area of coverage and thickness due to warming ocean temperatures and warming air temperatures. Warming air temperature has resulted in less snowfall, hence more rainfall. This causes more ice melt. Now, research has shown that rainfall in the Arctic speeds up the ice melt by 33%. Rainfall has the effect of warming the ice, so it softens the ice form, allows it to flow more easily. 2007-2008, there was a recorded abrupt decrease in the Arctic sea ice thickness. Now that's a real problem. 2023, the sea ice in the Arctic was thinner than ever recorded before. So it allows the ocean currents to move faster. So if it's moving faster, the ice can't thicken up as it would during the winter months. It's getting thinner and thinner and smaller. They think by 2035 to 2037, there'll be no sea ice in the Arctic over the summer months. That's crazy. So of course then they'll be able to explore for more fossil fuels. Great. This solar ice melt is caused by worldwide increasing temperatures, has a massive effect on so many other things. The ocean currents are changing. You're drawing more warm water up from the equatorial regions into the Arctic region, so you're speeding up that temperature increase. Think about Greenland, right? 2.144 million square miles. That's the coverage of that area. That's how big it is. It's bloody massive. I've been to Greenland a number of times. It's an amazing country. 82 to 91% of Greenland is covered in an ice cap, which has an average thickness of 2 kilometres. And now in the thickest part, in the central plateau, it's a beautiful place, it's amazing. There's huge lakes out there now because it's melting. 3.6 kilometres in thickness. It's hard to imagine ice can be 3.6 kilometres thick. It's crazy. Now, Greenland has lost, this is all satellite tracking, has lost 6 trillion tonnes of ice mass since the year 2000. I just don't know what that even looks like. This was recorded by NASA using 2 satellites to record the ice cap loss over the last 23 years. Polar ice cap melt is not a thing of a possible future. It's been occurring since the 1970s because of greenhouse gas emissions. Accelerated melt means the replenishment than the normal melt in the warmer months is completely out of balance now due to the increase in the Earth's air temperatures and the increase in the ocean temperatures. Even if we stop burning fossil fuels today, the melt that we're going to get over the next 150 years is going to increase our sea levels by over a metre. Now, researchers confirmed that we are locked in for a sea level rise of 10 inches by the year 2050. 10 inches. Now, this data was actually published in the New York Times, August 29, 2022. Now, keep in mind, what they were talking about was a locked-in sea level rise based on air temperature increases at that point. So not allowing for additional. Crazy. Now, according to NASA, for some data I read recently, if we lost all the ice in Greenland, it's inconceivable that could happen. Sure, sea levels would rise by 7.4 metres. Now, Greenland is the biggest ice mass in the northern hemisphere by volume and mass of fresh water. Arctic sea ice reduction. There's been a 50% reduction in the Arctic sea ice since humans have been using satellites to monitor the data. A 50% reduction. Crazy. This reduces the reflective ability, hence more solar radiation enters the atmosphere because of the loss of the reflectability of the ice. So, and also the Arctic ice, it borders the top part of Greenland, so it's protecting that ice cap from melting into the ocean, you see. It's just one thing just leads to another and another. The thickness of the sea ice across the Arctic has reduced 45% in the last 30 years due to the increase in air temperatures and the increase in water temperatures. Now, you're not only, you're just then opening up for further exploration in that region. So you've got massive reserves of oil and gas in the Arctic. It's becoming more accessible. So, you know, it's more financially viable for them to go exploring those regions now. So, but then you're burning more greenhouse gas, you're producing more greenhouse gas emissions. Insane. The Arctic sea ice does have a flow-on effect. It changes weather patterns across the planet. And the impact to animals that depend on the Arctic sea ice, it's difficult to measure, but it's only going to be negative. A loss, you're going to have a huge loss of species up there. The warming sea ice in the Arctic region, 5 times faster than anywhere else on the planet, 5 times faster, and the effects are devastating. Arctic amplification is here to stay. The rise of Arctic sea temperature speeds up the permafrost thaw in that northern hemisphere. So once you start to thaw permafrost, you're releasing methane gas trapped in the permafrost from decomposed vegetation over millions of years. Now, methane, 63 times more potent than greenhouse gas emissions that we're producing from burning fossil fuels. 63 times more potent. So it's more dangerous to our planet. And it heats up the atmosphere more. More methane, more temperature increase, more ice melt global, more permafrost thawing out, more increase in ocean temperatures, more ice melt. It just goes on, doesn't it? All right, now just remember, Arctic sea ice, the area coverage is reducing. Arctic sea ice thickness, reducing. 45 to 50% reduction in just 50 years due to greenhouse gas emissions, temperature increase. Look at the Himalayan region, right? It's known as the third pole. Our warming air temperatures is thinning most of the vast mountain range glaciers. Then you get an increased flood risk. The Himalayan naturally occurring water supply, it feeds close to 1 billion people. The drinking water supply for agriculture and industry. The Central Asian mountain region, it's home to thousands of glaciers, small and large. That meltwater feeds 10 of the largest rivers in Asia, 2/3 of the ice mass being fresh water. That will melt away by the end of this century. That's based on current global air temperatures with no further increase. End of the century, it's only 80 years away, folks. As the melt rate increases in the Himalayan region, downstream flooding is occurring. It's only going to worsen. Overflowing many dams built downstream to harness the flow of water for power generation. There's 251 hydroelectric power stations that feed from this meltwater from these glaciers. Now they're being overburdened due to the increase in flow, and eventually there'll be no flow, no power. They'll lose their power generation. Nepal and Pakistan, 2 top countries under threat from this climate change in the Himalayas. The Arctic region, the Antarctic region, West Antarctic ice sheet. We've got a glacial tongue sticking out called Pine Island Glacier, all right? Sticks out into the ocean. Now that glacier, that one glacier, the Pine Island Glacier, has accounted for 4% of the Earth's sea level rise over the past 30 years. This one single glacier has the ability to add 28 centimetres of sea level rise. 28 centimetres from one glacier. That's pretty scary. Edward King, glaciologist who recently released data collected in the Antarctic by mapping this glacial bed by radio wave technology. Edward King, interesting stuff he's published. This melt is happening faster than ever thought before. The Antarctic region is being affected by climate change more so than other regions across the globe. The increase in ocean temperatures in the Antarctic since 1950, so you got to remember that's only 70 years, right? 3% increase, 3% increase since 1950. 2022, Antarctica reduced to its lowest ever pack sea ice since I've been keeping records. 2022, lowest level of pack sea ice. You're losing that reflective ability, you're heating it up. Antarctica, it's a continent capped by an inland ice sheet 4.8 kilometres in thickness in parts. It contains 90% of the world's total surface freshwater. So that equates to 60% of all the freshwater on the entire planet is in the Antarctic, and it's melting because it's melting faster than it can get replenished. So it's draining into the oceans faster than it can get replenished. Melting. Think about what's happening. The Antarctic holds enough fresh water in frozen state, but melting, to raise our global sea levels by 200 feet. 200 feet. Crazy. Insane. Alarm bells should be ringing right across the globe. But no, like stupid little kiddies with our heads in the sand, we still prefer to plunder and rape our planet and extract fossil fuels at an increasing rate. Where are we headed? You've got to think about it. What are we doing? It's insane. Now, I'm off to the Marshall Islands in the Pacific region in a few weeks. The Marshall Islands in the Pacific is one of the very first places that's being really heavily hit by sea level rise caused by global warming. So I'll be interviewing some of the local folk there, and I'll be collecting some footage, first-hand evidence of these atolls and low-lying regions that are being washed away, that are being impacted by sea level rise. Thanks for watching. I'm Dave Lonergan, Arctic Film Productions. Please stay tuned, as you are.